Hey guys, welcome to M3D's Facebook Live. We're going to take about 30 minutes here to do a Q&A about the 5 products that we launched earlier this week. So, thank you for joining us, and we're going to go ahead and just dive right in.
Overview?
Oh, what's behind us? Oh, sure, yeah. So, behind us we've got a few things going on. On the right, we have the QuadFusion print head here, and that's plugged into a MakerBot with a fairly simple adapter. It's actually one part and 2 screws. And what that's showing is that it's compatible with any printer. It makes for a fantastic print head to have. And it is doing PETG, what we call ABSR, in 4 colors. Now, these aren't ideal primary colors. We're just showing that you can create really cool gradients for the time being. So it may not be obvious if you look at the end result, but that is actually a mixing of 4 colors. And the reason is we've keyed some of it in the middle with black, and we've keyed all of it with clear. So we're actually getting a slightly lighter, deeper color object with more depth. So if you were in person, you'd see it has a bit more shine than a typical object. So that's a really good demo print. On the left, we have the prototype crane quad, and it is doing some color changing operations. So what we're printing is a little half wedge. So it's a little half wedge, and that's just showing that we can change colors within the layer. And these are relatively quick changes to go from black to pink, for example, or magenta, but we can do quicker changes in the middle. We're just ramping up our calibrations here. So the printer right now looks like it's getting ready to switch to blue, and it is doing that without a waste filler. That's really the important demonstration here. So if you look on the left, you'll see some blue. If you look on the right, you'll see a little bit of yellow, and we're doing that with very little runway. It only takes about 20 to 30 millimeters of distance to purge out one color and really start to see the new one come through. So there's some real opportunities here. In fact, we're talking to some contributors out there who are going to make plugins and have already had success doing what's called a look ahead, where they actually advance the G code so that when the color change happens, it's timed to where you want it in the print. So there's certainly a lot of development that's going to be done that's going to enable this. So actually, let's switch to Bowden real quick, since we talked about the quad. Bowden is really just fantastic at producing high-quality prints. If you go slow with the machine, the Bowden really can keep up with its extrusion at a super consistent rate. So this is not a vase mode print. It's actually, you can see the Z lines right there where it hop upwards. So we're not cheating and giving this printer the maximum possible chance at producing a high-quality vase. This is just its normal print quality. This was around 65% speed. Once you increase it to 100, you lose a little bit as far as quality goes, but the printer can move pretty fast. Let me do a quick demo of the waste pillars. So this is actually an enormous accomplishment. This is the first time that we focused on switching colors within the same layer. And we had to modify the G code a little bit to get a reasonable size waste pillar. And we believe this is the first time there's a waste pillar with this little waste. In fact, usually you'll find a tiny object like this will have a waste pillar that's 5 times as much material. And that's because the QuadFusion print head has such a small mixing chamber at the tip. We calibrated that mixing chamber so that you could really decide whether you wanted to switch colors completely and purge out one color, or if you want to merge them together. Now, we're still finalizing those protocols for ideal color mixing, where you get perfect color mixing without any striation. So, for example, if you look at one side of this print, there's some slight variations, and that's because we're using an earlier version nozzle that doesn't have all of the refinements in it. So one of the refinements is you go with a smaller nozzle diameter, and that allows you to better mix. You can also better mix using higher temperatures, and one really sneaky trick is if you lower your nozzle height just a tiny bit, your mixing chamber doubles in size. So if you want really smooth color mixing, we believe you can achieve that for the first time and not get the toothpaste stranding. And that will only come at the cost of you probably need to have a slightly larger waste filler to switch between mixed colors. So it's a little bit in development, but the proof of principle is really there. So we've talked about QuadFusion printhead and the cranes, and last but not least, this has really become the workhorse. So this is the Duet Maistro, and its legacy is based completely on the Duet Wi-Fi series, which is the Duet 2. And this was designed by the Duet 3D team in the UK, with a little help from M3D to guide what we wanted as an OEM, an original equipment manufacturer. So there's certainly a lot that is on here that we kept. In fact, we paid quite a few dollars for extra headers and chips so that you guys could expand. For example, there's servo controllers down here. You have the ability to have a SD card extension slot, a standard 12864 LCD. You can also use the Duet 3D touch LCD device. And we have two headers here, which is a motor expansion. Now, when you plug this expansion in, you go from 5 total drivers to 7, and this is what enables QuadFusion printhead. And it's not a very complicated add-on, it just gives the microprocessor more channels. And what's beautiful about the way this has been designed, the RepRap firmware is very versatile in being able to add or configure multiple drivers, heaters, and sensor combinations, and it really treats each individual driver as just another number of drivers. So it's not like your X and Y are linked together, but you can't link it to your Z and your E. So it's a very efficient system, it's very versatile. One of the changes that we made is we put a very high quality, very high current capacity connector here. There have been problems in the past with these little screw terminals, so we wanted something beefier that you would see on a normal DIN power supply. So these can handle 30 amps input and output for heaters. The actual board might only be able to handle up to about 18 amps for a heater, which is plenty of power if you're 24 volts. The actual heaters going to the extruder, we have direct contacts there, in addition to people that want to use their own that they screw in manually. Lots of end stop configurations. You can power it with an ATX. There's simply a jumper that you would have to remove somewhere around here. You can also power it by USB or the input voltage directly. There's a micro SD card slot here. Now, I think this is important to point out. This is essentially the memory for the device. You can upload to it using Ethernet and with the web host, but it is primarily intended to stay on the device. You can remove it, but we recommend leaving it on there and using one of these expansions to add a second card slot. Ethernet is by far the most unique thing about this board. This is really putting you in enterprise territory. And what we found in our early testing is that Wi-Fi systems in general can be a little bit flaky. They can have somewhere between a 5 and 10% failure rate just because of different network configurations and the overall reliability. You need a very expensive chipset to be able to get very reliable Wi-Fi. And so if you're in an environment where you have a fleet of printers and you want to control 10 or 20 machines, we find that Wi-Fi signal saturation and speeds and reliability, trying to ping your device, starts to become an issue. So we decided to go with Ethernet as the stock solution. If you need to make it Wi-Fi, that's not a big deal because you can plug this into a router or make a bridge for something like $13. You can buy Ethernet to Wi-Fi bridges online. So it's an extremely versatile board, it's a powerful processor, and this is really premier. This is the latest generation of open source technology that you can get, and it has plenty of power for our application, and it's plenty expandable for people that want to modify their heads. So that's the overview, and we're going to go into Q&A in a second.
So we've got one question about the motors. What motors are you using in the
Motors in the QuadFusion?
Yep.
You have one of the separate printheads you could grab for me?
Yep.
That'd be much better.
So let's have you repeat the question.
Yeah, so the question was, what types of motors are we using? So our original innovation that led to M3D in 2013 was we were looking for a very low-cost motor to put into a very small space. And so we needed to create a highly geared motor. We wanted it to be a stepper, and it worked extremely well, but it also happened that there were lots of little details that evolved. We actually have over 14 generations, a lot of patent pending additions to these motors. So you might be able to find something stock online for $5, but it's just not the same thing. And we have genuine Delrin going into the gear train, we have metal gears, we have bearings, and a number of other innovations. A gear shaft that's made of a specific type of steel that can handle the cycle loading and the lifetime. So what we realized was after about 4.5 years of honing this technology that these motors were perfect and as an extruder motor. And the reason is they're highly geared. It's 1:64 gear ratio. So that means even if you didn't have micro stepping, you would get insane accuracy. You don't really have much backlash to worry about in an extrusion system. That doesn't come into play, especially if you have retraction anyways. It's a sort of backlash in and of itself. And these motors are okay for an XY system as long as you're moving slowly, but when they're highly geared like this, they're virtually flawless for an extruder. They take very little space, they don't overheat, they don't need too much power. As you guys will see, we believe we've really nailed it with the previous generation of these motors. We have not been able to find a failure yet in the last 1.5 years. So we decided to refine it one last time, give it a black enclosure, and we just call them 135 blacks now. So this is what we think is the final evolution of this motor, and we've pushed it as far as it can really go. So we're very happy with the performance that we're getting out of these micro gear motors. All right, what's your next question?
Question about the waist pillars. They wanted to see the waist pillar for that print you were holding up, and roughly how heavy it is. How heavy is it?
For this one?
Yeah.
Okay. I think it'd be easiest to get a scale, but we're looking at maybe somewhere between a tenth and a fifth of the weight is this waist pillar. Now, obviously, this is probably the worst case example for that. If this print was larger, you would not have to have any additional waist pillar. So the way the code is supposed to work, ideally, is you would print everything that's yellow, have a little bit of waist pillar, switch to the next color, print everything that's black, and so forth. So you only need to switch 4 times per layer. As the software gets smarter, there's certainly going to be ways to improve that. For example, maybe not every single layer is going to have to use all 4 colors.
Why color printing? Why is color printing cool?
That's a very good question. So we actually...
The question is, why is color?
Oh, so repeat the question, sorry. So why do we want to 3D print color? Besides the obvious, effect that lots of colors and lights have on just us as humans, primarily, I think this looks like a more complete, more real, more interesting object. I think anybody who's started a 3D printer company knows in the back of their mind, step 1 is we're going to make a good printer. Step 2 is we're going to enhance it. And the enhancements are really essential to realize where 3D printing is going to be eventually and where it needs to be. So the example that I usually use inside the company is take any object, I'm actually looking for one now, but take any object, a remote, a router, some device that's near you, and you're generally going to see that it's made of 2 to 3 colors, maybe 4. So you don't need a lot of colors. Let's go over there. So you don't need a lot of colors, but you'll find that a complete, meaning a finished product, is not usually just one blob of a single color. You need 2 or 3 colors in order to break up your final product. The product essentially is following standard industrial guidelines, which typically means when you have an interface, like a button or 2 parts that are merged together, you want to have 2 different colors so that you essentially hide the assembly interface. And a lot of times you'll see more embellished objects that actually have 2D inkjet printing on a surface to make them full color, or they might be painted by hand. So to have 2 colors and above is really the beginning of a 3D printer, especially a filament-based one, being able to pump out an object that you can grab and it actually looks like a complete product. It doesn't need to be cured in the sun, it doesn't need to be sanded, it doesn't need to be painted. So just again, to summarize that, it's the color that kind of deceives the eye, and it gives the impression of a much more finished, refined product. So that's where we think color is going to help with, initially. The ability to also have a single exit point is something that manufacturers have really started to converge on as a solution. It's really been in its infancy for a few months, but what we call a compounding nozzle saves you from having to calibrate two individual nozzles, losing the space, or having nozzles bump into your print. So the ability to swap between a support material and your main material is another immediate advantage that we're going to see. Another advantage that you're going to see is simply the ability to produce colors on the fly. So we have we have hundreds of spools in here, and we don't even always have the colors that we want, or we run out all the time. So the ability to have 4 or 5 starting colors and make any color that you want for your specific project, even if all you're doing is one color in your print, is still a pretty big deal, because that saves you space and time and money and inventory and having to worry about it. And I think the final advantage that we're going to see that's going to take longer to realize is the ability to merge materials and have mixed properties. So a good example that we see immediately is people are going to print one component of rigid and one component of either flexible or rubbery. And there's so many examples that we could probably come up with where that'd be useful. One example that we came up with internally is we have a lot of places where we want to screw things into each other, and it is really difficult if you have a hard object because you have to tap it and then screw it in. But if you have let's say a ring, and then the inside of it is lined with rubbery material, you can actually screw straight into it, or use something that's self-tapping without any risk of damaging the print. You can also make joints where you have one component of rigidity and one component of shock absorption, and that's just what I can come up with, my limited thinking. You guys always come up with examples that really blow our minds. So.
Does M3D have a color key filament available?
Color key.
Yeah, how are you dealing with colors and the color key filaments?
Okay, so the question is, does M3D have color key filaments available? So what the question is really asking is, have we created a base system that you could use and have a predetermined color map? In other words, we align the colors and the ratios for you, you just buy our predetermined color schemes. The answer is yes, we have cyan, magenta, yellow, and these are color calibrated filaments, and that's extremely important. We've got shapes and sizes of particles in there that give you a reliable mixing ratio. So you're going to have a 2 to 8 micron particle size range, and you want spherical particles. As far as it goes, hang on, I've got to clean the camera up now. As far as the mixing goes, you don't want to take something that's got a very wide distribution of particles. So carbon black, for example, which is basically burnt coconut shells, is typically what's used to color black filament, and it's a very poorly controlled material. It's a wide distribution, lots of different particle shapes and sizes. So what you would find is if you were to buy black key to print with, if you were to say take yellow and purge it out, you would find little striations of black particles kind of showing up for a couple 100 millimeters. You'd have to spend a lot of wasted yellow in order to purge it out. So we do have black keys, we have clear keys, white keys, and we're also making it available in 4 of our materials, the most popular ones.
So another follow-up on that is, are you planning on any more than 4 filament heads? You don't get a full true color spectrum without black and white as keys. So how are we going to deal with that?
Sure. So I think it's, so let me repeat the question. We have 4 colors available for mixing. Ideally, you would have 6 or more. In theory, you could have 8. There's the more advanced machines that do inkjet printing will use 6 colors, and you can still get pretty good color palettes with 4. So there's a couple ways to approach this. One of them is this is a significant advance in the industry towards full color. Our color palettes are pretty robust, especially if you know what you want to print. You're usually going to be able to find a combination of colors that work. So let's say that we were trying to print my pet golden retriever, if I had one. Well, we don't really need magenta for that print. What we would really focus on is black, white, yellow, and maybe one other color, like blue, maybe even a gray, so that we can get the right definition in something like the eyes and the fur. So that's one example where the color palette can be about as refined as you would need, and you would still get the end result. But I would also say that we're exactly one step or one half step below something like photorealistic. You know, printing someone's face is, some people are going to get pretty close, but they might need special keys to pull it off. So yeah, I think the industry essentially started with 2 and then went to 3, and there was, I think, one attempt at 5 briefly. We could certainly go to 6 in future editions, but I feel that before we go that far, we would like to see us as curators for the community and the ecosystem develop some slicer plugins and really hone the craft of 4 colors just before we move on to 6.
Nice and simple question. Someone bought the Bowden version and they want to know when they can buy the upgrades.
Okay, so somebody bought the Bowden version and they want to know when they can get the upgrade. So it's a good plan if you want a low-cost printer where you commit, have the least risk, I guess, have the least exposure, and upgrade it as needed. The upgrades are actually coming on quite nicely. In this campaign, we're trying to really overpromise and underpromise and overdeliver, rather. Shouldn't really want to do it the other way. So we have the heads, we have the boards, and they are actually surprisingly ahead of schedule, but we don't want to really get ahead of ourselves there. So we believe the add-ons will be ready quite in advance of delivery of the actual Crane Foundation printer itself.
Very specific question. Will this have similar issues to other mixing hot-ends, such as color biases in the respective entry points in the nozzle?
Color biases in the what?
Color biases in the nozzle. So, toothpasting effect. How are we going to deal with that?
Yeah, so we touched on this a little earlier. The question was, is this printhead, like others, going to have a color biasing effect? We certainly are improving it drastically. I don't know if we're going to ever eliminate it 100% if you're going to have any reasonable waste pillar sizes. But again, the way that we're solving this is we're making the mixing chamber a bit controllable. We're making it a little bit larger, and we're going to recommend certain materials, temperatures, and nozzle tip size combinations if your goal is to maximize the best possible color prints as far as mixing goes.
Okay. What comes with the Crane Quad from a fit-to-lunch purchase? Print heads, full unit, on your desk, heated table. So what's all included in the Crane Quad?
Sure. So I think the description, so we have a really nice, it's like a 4x6 feature diagram that really explains well what you're getting. It is really feature loaded. You're getting a complete assembled 3D printer with the 2020 frame style, assembled with the B wheels. It comes with a heated bed, and it's a fairly fast heated bed at 24 volts. It's an aluminum substrate. We do a lot of quality control to make sure that it's flat, and all aluminum. If you wanted to, you could add glass to it, but it doesn't look like it's necessary at all for this size printer. You're getting the LCD, which is a standard RepRap 12864 style LCD. That gives you a great deal of immediate control. So that's your instant gratification. You put in your micro SD card, you scroll a little bit, you hit print, and it's done. You get the Duet, which comes with just numerous features, the web interface being one of the biggest ones, the Ethernet. That also gives you some pretty good options. I wouldn't say they're a replacement necessarily for an Octoprint type system, but there are servers out there that you can set up so that you can remote dial in and control the fleet of printers from one interface, one web browser, for example. And we'll post those links up. You're getting the NEMA motors for everything, as well as the 135 black motors that we have in the print head. If you're getting a Bowden system, you're getting all NEMA 17 motors. So the Bowden feed is a NEMA 17-based MK10 style extruder. Power supply, everything that you would need to get started is included except filament.
Next question. How are issues with backfill being addressed when you don't want to have 4 filaments loaded? Second parter to that question, are there a lot of clogging issues in your tests with single filament feed?
Test with single filament feed clogs?
Yeah, so if you're only putting one filament in.
So the question is, there's sort of a dichotomy here, right? We've designed a print head to handle 2 or 4 filaments in mixing mode. So what happens if you just want one? Print head definitely works perfectly fine as a single filament extruder. We would generally recommend, since overall we're recommending materials under 255 degrees C. We recommend putting a plug of thermally stable material in there. So we provide a little short strand of basically polycarbonate filament that you can use to plug the channels that you're not using. That just helps keep the system cleaner and more reliable. Worst case scenario is you can just push out any material because it will backflow a tiny bit until it hits the gear motor, and then the actual gearing is strong enough to keep it from pushing its way upwards, so it doesn't create any clogs or anything like that. The only downside that does seem consistent between different systems that we've looked at that have already been out there for a while is that PLA does degrade at temperature. The actual molecules get smaller. It becomes more like a nasty dried honey rather than actual PLA. You can still extrude that out for a good while, 10, 20 hours, but at some point it's going to kind of get gunked up. So if you're going to leave several colors of PLA in there unused, you shouldn't do it for too long. And that's why we recommend the ideal material for the mixing system be PETG based or ABSR based as we call it. It is an ideal material for many ways. It's taking over the industry. It is either leading our sales now or about to. It is far superior. It requires less force to crush and move forwards. It can extrude faster. It bonds better in many cases. It is more versatile. It's got a much higher temperature transition. It's just a better engineering material. So that's really starting to take over in for many different user bases in 3D printing. So if you haven't looked into it too much, you definitely should. It does rely on a heated bed or a glue stick just a little bit more than PLA, but it has pretty low work too. So.
Combination of two people's questions. Is there a current solution available for taking a model exported with color information and getting its slicer to generate the G-code needed to control the quad, coupled with how hard will slicer plugins that make color be to use? And so I think we might want to take the opportunity to talk to the whole color ecosystem.
Yeah, no, so it's a tough question. The basic question is, do we have a complete protocol from beginning to end for printing in color, and how hard is it to incorporate software, plugins, things like that after the fact? Well, the second one's very easy. The community is already doing it. We, in fact, got our gradient prints working by using somebody's plugin already, and we generally find that the mods we have to make in order to get color printing working are kind of basic, kind of lame, to be honest. So it's really that the slicers have this capability of having multiple extruders, and so does the firmware, but mixing really wasn't on their mind. So they do almost everything that's necessary stock, except they'll usually goof up in one or two places, like you'll go to switch colors and it'll extrude too much material for some reason. So we usually have to go in there and apply one post-processor in order to get it working, and those are protocols that we are writing right now. We suspect, since so many people are going to be getting this hardware, and we're going to be nurturing the ecosystem and the community, specifically people that do this a lot, as well as slicer developers, that it's going to get better pretty fast. So for the first run, as far as color combos go with two colors, we're pretty close to finishing our refinements in how to process that, and that can be done with stock slicers. As far as four colors goes, it's the color changes that need a little refinement in those code bases. So we think plugins are definitely one of the solutions.
Nice and easy one. Why no Wi-Fi?
Yeah, so questions why no Wi-Fi, and again, we touched on this earlier. We just found in our testing, if we wanted a happy user base to have consistent results, the act of connecting Wi-Fi can be tricky, laborious, inconsistent, and sometimes a bit slower. Whereas you plug in an Ethernet and it works every single time. So we just don't want to take the chance with it. We've seen companies buried, frankly, that gambled on just Wi-Fi and a few other connection methods. And as a semi-commercial user, we have a lot of phones, machines, equipment in the building. It's not, as concentrated as a trade show, and it's not as light as your house maybe, but it's somewhere in the middle. We find that Wi-Fi signal saturation, network speeds, router capabilities tend to be surprisingly limited in this environment.
How does the print quality of the Bowden compare to the quad head when printing at slower speeds with a single filament, for example?
So the question is, how does Bowden print quality compare?
Yeah.
Okay. So the question is, how does the Bowden's print performance quality overall compare to the quad heads? As far as we can see by eye, there's no difference in terms of the print quality at slow speeds. I would say that the direct drives have a significant advantage at printing faster. And the reason is, and by the way, it's one major advantage of the Duet system, is that RepRap firmware is one of the few code bases that has what we call a look ahead. It's actually called a pressure advance.
Do you want to walk to it or no?
No. Oh, you have the yeah. Let's go over there. So are we live?
Yeah.
Okay. Sorry about that. So we have a Crane Bowden here printing a fairly difficult print with a lot of retraction and hopping around. And so to get back to the question, if we slow this machine down another 20-25%, that's really where we start to get quality that matches the direct drive system. Not really losing in terms of resolution, in terms of accuracy if you go fast. It's just there's a bit more jitter that you get because of the way a Bowden feed works. It has a little bit of trouble reacting quickly, and so you actually need to slow down your acceleration moves as well as your print moves and your extruding moves in order to let the pressure build up and be consistent or really just react. With a direct drive, you can basically yank the filament faster and get a more immediate response. And so that's, I would say it's a 35% speed increase at least to go with the direct drive if what you're looking for is the smoothest possible finish. For a lot of engineering applications, like just getting a part that you connect to something else, you're not going to care and you'll just push the speeds anyway. And while we're on that, let me show them so this was a fairly early test print. Sorry, I'm too close to the mic. So this was a fairly early test print. We didn't do anything to slow this one down. So you see maybe a tiny bit of that striation on camera, if at all. I think you see it a little bit on the columns where it's just a little wavy. But it's a pretty darn good first test result considering we didn't have a lot of time to optimize our fan designs and our actual G-code or slicer settings. So it's a pretty good first result.
Quick next question is it feasible to think that material mixing with FDM can get photo level color detail in a single print? Wouldn't that require very intricate level slicing? Would that even make a viable print? Needing to almost print a pixel, then purge, then print another pixel, etc.
Yes. So the question is, can you get a photoreal print with a filament-based printer? It would be challenging today, to say the least. We certainly aren't promising a photoreal result, so don't expect that. We are promising a half step or a step below that until there's more development around it. So the person asks or suggests that what you would need to do is you would need to change to one color, purge a lot of material, set down some really tiny subpixel and do it again. And that's not what would ever work. It would be impossible to get quality or speed or reasonable material usage. What would happen instead is that you could probably get very close to photoreal eventually with certain prints. So something that has a pretty nice, consistent, smooth outer wall will probably be the starting point for this, and someone would have to write a lot of code to make the extruder essentially look ahead at what's coming, and they would have to optimize the path to figure out when to start changing colors, and it would cleverly kind of go to the inside of the print, change color, and then go to the outside and lay a pixel down essentially where it needed. In the Z direction, you can get a lot of resolution, and it's because you can really lay down thin lines. So you'd be able to get pretty darn close to photoreal in the Z. In the X and Y, you wouldn't be able to do as well, so it'd be a bit more pixelated. And there's certain cases where it would be very close to photoreal because you don't need the XY resolution, you might only need the Z. But no, I wouldn't say it's a reasonable expectation to think you're going to get a glossy Polaroid photo style finish on any print anytime soon.
Last question is opposite. God forbid there's a clog. Are the heads easy to clean and disassemble? And then on the flip side, if everything's working well, how fast can you extrude if you load all 4 chambers, if you will, with the same filament color?
Okay, two parts to that question. The first part was, God forbid there's a clog, how do you fix it? So in this system, we have a fairly standard style PTFE tube. We have been doing this for quite a while, so we've been refining our nozzle designs quite a bit. So there's a few things that M3D does that I don't think, even to this day, the industry doesn't appreciate and hasn't copied enough. They copy a lot of things, but not this one. It's pretty typical to see a tiny nozzle, because they're very low cost to make when they're so small, and to screw it into something. And when you do that, you create a lot of space internally for filament to get stuck and essentially tarnish and blacken, and that becomes your seal in some ways. And that also becomes a place where you harbor lots of black charred filament that can either smell bad or start specking into your print and messing up the quality. Those types of machines, if you get a clog, you'd usually heat it up, take out the nozzle, maybe throw it away and put in a new one, or you'd have to go in and clean your block. We consider that pretty scrappy. So what we created is a seamless nozzle system. The actual nozzle, if I have one here, the actual nozzle has a couple features on it. The first is it's got a set screw that fits into a slot, so that locks in the vertical position, so you don't have to guess what your position is vertically, so you don't have to recalibrate anything because of how tightly you screwed something in. We also have it all the way to the end seamless. So in many small nozzle systems, we find that they leak either from the bottom or the top. But the important thing is this sleeve. If I can grab it. This is a PTFE sleeve that's on the inside that you can probably grab with a pair of pliers or something. And you can change this thing out very easily. There's not a lot of complexity here, and everything above, it's basically impossible to get any sort of clog up there. So we designed the system to be pretty darn efficient when it comes to material changes. The second part of the question is really, I think it's inspired. So the question is, what happens if you fill up all 4 slots with the same material? Can you get faster print speeds? The answer is definitely yes. We'd like to see more. So tentatively, what we're seeing is roughly about a 2x print speed, and it really depends on your material. 2x isn't small. Most printers are actually limited by their extrusion speed, not their actual XY head movement, unless they're printing really tiny layers. So with an extruder, what you have to appreciate is the material, as it's heating up, needs time. It's not so much a matter of how quickly it's getting the heat. It can be at temperature, but still extrude like crap. So to get that nice honey extrusion, you really need a couple seconds at temperature, especially for polyester-based materials like PETG and PLA. PLA is kind of the worst in this regard. It really defines its own maximum extrusion speed, which tends to be around 3 to 3.5 millimeters a second of actual filament movement. So if you load up 4, you definitely get an increase for a couple reasons. You have generally more surface area touching the walls. For each one of the channels now, instead of having one move really quickly, you can have 4 of them moving a little slower. You also get more extrusion force. You actually have about pretty close to 48 pounds of force maximum if you're pushing with all 4 of them, which is why we have such an aggressive slot in the nozzle to keep it from moving. So that's a lot of energy, let's say, both force and heat. So you can get an enhancement, but if you really want this thing to cook, it's kind of a scary finding and a cool secret. Carbon fiber-based materials can extrude faster than anything. We're talking like 5 times faster. And there's a few reasons for that. The carbon in there is essentially like a graphite. It's aligned with the direction of motion. That is extremely good at conducting heat. It's basically as good as something like aluminum in terms of its thermal conductivity. It also is self-lubricating, so it doesn't lose energy to the friction in the walls. And it's also diluting the mass of PLA by about 30% that you would otherwise have to heat up. So what happens when you put carbon fiber in there is you really can't move the print head fast enough to extrude. It sucks that it's a bit of a more expensive material. It's hard to granulate and shear mix it and get the formulation. But there are tricks like that that let you get closer to a 2 or a 3x or even a 4x speed increase. So carbon fiber would give you the 4x for sure. Going to PETG gives you about 2, 2.5. With PLA, we're not seeing as much speed increase as we would like if you did all 4. So that's still a number that we want to refine and see what we can get it up to. I think the secret for PLA is to have a bigger mixing chamber so that it just has more time to heat up.
All right, that's all the questions that we have.
Okay, that's all the questions we have apparently. So, thank you for your time. We'll certainly be doing a couple more Q&As in the next few days as things really start to heat up with the campaign, and we are expecting to see some pretty good results here in the next few days and weeks. So, thank you again for your time, and we will finish by.
Oh, wait, we got one last question.
Yeah, go for it.
Does the crane system come with software to convert 3D objects, OBJs, SPLs to G-code, or do we need to get software to create the G-code? Example, I used the Rhino cam for a CNC for objects from Rhino.
Yeah, so the question is, are we offering?
The answer is, are we softwaring? No, right?
Yeah, no. Are we offering software? No. Are we offering settings and guides and a place where people can curate, help us curate those settings? Yes. I think it's important to point this out. What open source is not. It is not. We make hardware and say, yeah, go out and figure it out, and we're gonna get a bunch of free developers. That's not what open source is. And open source is also not. We're gonna control everything and make weird licenses and not help anyone. The real middle ground here is what we're going for, where we are paying some developers, where we have our own developers, and we're going to serve as essentially one cook, where we're going to curate and we're going to get pull requests, merge requests, things like that, but we're also going to go out to users where we've seen that they've done good things with our code and bring it back into the main code base. So we think with that approach, we're going to be advancing pretty quickly because there's a lot of developers in this group that are going to help us get those settings locked down here in the next few months. Cool. All right, thanks again.